My seventh period. Okay, we're going to be doing a lab today where we are going to make a cart go down a ramp, and we're going to call it the cart down a ramp lab. Now, when I let this cart go, I want you to look at it, think about it, and I want you to share what you see it doing. And think about it in terms of motion. I said think, don't talk. One more time. Okay. Raise your hand if you want to share what it's doing.
It's accelerating.
It's accelerating. What does that mean?
It's increasing its speed as it moves.
Increasing its speed as it moves. Were you going to say something?
No, that's what I was gonna say.
Copycat. Yeah, I mean, I think that's a basic thing. It's getting faster and faster as it goes down. Okay, I don't think we're seeing anything that's groundbreaking there. If I asked a question of what's happening to the positions as you go along, how are they changing? The position. How? So as this thing goes along, there's a change in position. How can you describe how the position is changing? That's a little trickier question. Does anybody have an answer? Raise your hand. Nobody has an answer? Not even a guess? Chloe? The positions are increasing? Is that it? Yeah, because we start up here, we start with a zero position. As you go down, bigger and bigger position. But does that describe the whole story? What type of increase of position change are we having? Well, positive, yes.
Displacement.
It's a good word. But is it a constantly changing, increasing position? So is the position change up here the same as the position change down here each second? Where do you have a bigger position change? Down here at this time or up here at this?
Down.
Okay. When you guys did the buggy lab, how did the position change every second? Constant. Well, we don't have constant motion anymore. So whatever your feelings were about the constant motion we had our second unit, that was easy. Now we're throwing this whole different motion in there. All right, so keep that in mind because when we do the lab, you guys are going to look at how the position changes as time goes by. You're going to look at how the velocity changes as time goes by. And you'll also look at how the velocity changes as the position changes. And you are going to come up with those three relationships on a graph, and you're going to do the data collection in less than 2 seconds. So you're doing 3 experiments like the pendulum lab. But you're not collecting data for experiment 1, experiment 2, and experiment 3 separately. You're going to have each relationship collected at once. And the reason we can do that is because of this thing right here. This is called a motion detector. It's called a motion detector because it detects motion.
Whoa. I just wanted to call it that.
This is a motion detector. It's called that because it detects motion.
Did you get that?
So
Robert?
let me briefly explain, maybe not briefly, but let me explain how this works. This has applications you're familiar with. So this thing, when I tell it to go, it will shoot sound waves out. And the sound wave will get shot out until it hits something, and that sound wave will bounce back, and when it bounces back and hits here, you'll hear a click.
Fancy.
And this thing will measure the amount of time it took for that sound wave to go there and back. and it knows the speed of the sound wave, 330 meters per second, and if it knows the speed of the sound wave and it knows the time it took, it can figure out how far the object is away by doing a little calculation. Now, it doesn't just shoot out one sound wave. It shoots out sound waves, a bunch of them every second. You'll hear a lot of clicks. So my question to you first is, where in real life, outside of the physics lab, would something like this be used? There are
At the
several.
location.
Wait, hang on.
Police
A radar gun? Yep.
At the location.
Yep, Del.
Your speed.
Yep.
Wait a minute.
Oh, yeah, so cars can self-drive. Yep.
Hey.
Those with.
I forgot about that one, that's a new one.
Big
I couldn't
brain.
talk about that when I first started teaching. If I shoot this going down into
Sonar.
water on a boat,
That'd be sick.
depth finder, fish finder. Who's a golfer in here? Where's a golfer?
And Ben Ryan. Shut up, Ryan.
Okay, have you ever taken something and shot it at the flag and you found out how far you were away from the flag? Okay, rangefinders. You can get those out on the golf course. Who hunts? Do you have a device like this to see how far a deer is away? Yes. Good video work. I'm trying to think of, I have one in my head, I can't think of it right now. But I think you guys get the idea. All right. Now, before we get into the lab, I want to have some fun.
Oh.
This is the most maximum,
Oh.
we're being recorded. Maximum amount of fun you can have with the motion detector.
Let's just put Katie. Wait, Robert, no, stand in front of it.
We're going to measure the motion of people in this room. In seventh period, sorry, you can play around with this, but you're not going to be able to do this with me. That's okay. You'll see those graphs later. What I'm going to do is I'm going to open up a file that is in the folder Physics with Vernier. And you can find it if you want. You can do this for fun. But I'm going to go to 0-1B graph matching. And what will happen is, it'll show a position graph that's already drawn for you. But it's called graph matching. So I am going to randomly select a person to walk back and forth in front of the motion detector so it can figure out how far you are away each interval of time. And you're going to have to do that motion right there. Morgan, you want to try to do it?
What do I need to try and do? Just
I need you to walk back and forth and do that graph when I say go.
do that graph.
Do that graph.
Yes, Morgan.
I don't know how to do that graph.
Well,
You just walk like the graph says.
like every first person that does this, you probably will do poorly.
I'll do it.
But that's okay.
Okay.
I know what to do.
Now, hold this board. So, there's a reason I'm having her hold the board.
Okay.
When this thing shoots sound waves out, it likes to hit flat surfaces so it can bounce back perfectly. That's why when you do this lab, you're going to have a note card on the card, so the motion detector hits the card evenly every time. Now, when I press collect, I can't do that yet because I haven't plugged this in. When I press collect, which is that green thing up there, these are in the instructions posted. Right now,
Sounds like a taser.
it's hitting something.
Yeah, right.
Every click is a sound wave.
Back up.
not doing anything right now.
Okay.
Let me see where that was. Okay, the motion detector was hitting something that was over 3 meters away.
Get the 1 meter away.
So all I'm going to say is, these positions are positions of how far you need to be away from the motion detector. Now, when I say on your mark, get set, go, I'm gonna press collect, and there's gonna be just a small delay, and then it'll start clicking. When it starts clicking, that's when you gotta start moving. You seem really nervous.
You have to go back and then stay there for a while and then.
So think about what you have to do, yep.
Wait, can I ask my?
Phone a friend?
Yeah.
Pull the audience, sure.
Science wizard.
So you have to start there for a little bit, then you slowly walk backwards. Okay.
After a second.
Then you stay there for, you know, and then you walk
You know.
forward a little bit and stay there.
Stay there
Okay.
for,
3
no.
What? What quantity does you know?
Yeah, exactly, I'm confused.
So I stand, I walk back,
Then you stop, and then you walk forward a little, and then you
but not, don't walk all the way to where you are now. Don't walk.
half of it.
So here's what you're gonna do.
These are times done.
Stand still for 1 second, then walk backwards for 2 seconds, then stand still for 3 seconds, then walk halfway the distance that you walk backwards in 1 second, and then stand still.
Yep,
Got that?
just like that.
Give
Okay,
her like a
on your
map.
mark, get set,
Oh,
go.
wait, there's one right there. Oh.
Oh.
Um,
Wait a minute.
That was pretty good.
It was kind
We can walk.
You are literally going to disprove me. I have zero expectations that first people can ever do this, and you were right on it, but then,
Yes.
here's my point, thank you.
You're pretty close.
All right,
You're pretty close.
Jason, you wanna try it?
Let's go, Jason.
No. Okay,
Come on, Jason.
Robert?
Yes, Robert!
No, I'm good.
You
No,
can do it.
no, you're doing it.
If I
You're
can do it,
doing
you
it.
can do it.
You're doing it.
Tanner? Oh, Robert, you're gonna do it?
Yeah, Robert's doing it.
Yes, Robert.
Let's go, Robert.
Robert, just like look at it.
I don't know.
Just look at the thing, you know what to do.
There. One more step.
Let's go, Robert.
No, forward. Yeah, right there.
Your mark, get set, go.
Then move it. Walk backward. Stop.
Ryan, what, who told you to listen to Ryan?
Yeah, I thought that was.
That was pretty good.
That was good.
Yeah. That was
No.
the same
Hey.
Hey!
I was listening.
Oh, he's looking. He's looking.
Shims.
She's like, what?
You're next on the Price is Right.
Oh, wait, gotta put her phone away first.
This is why we don't do it too long. It's stupid. Ready? Here.
They heard that.
Not even holding it the right way.
Okay, do that.
So start further back.
Good check.
Right there.
Right there.
Forward, stop, forward, stop. Back.
Okay, you're gonna go for
Forward for
move
3 seconds.
forward for 2.5 seconds. 3 seconds. 3 seconds.
Stay for 1
Stay
second.
for 1
Then
second.
move forward again for a second. Then stay, and then walk backwards. Oh, yep, you got it. Ready? Okay.
On your mark, get set,
Are you ready?
Go.
Oh, wait a minute.
So on track though.
Hey, look at that. Hey, that was pretty close at the end. Hey, the end was pretty good.
Let me do it again.
You started strong in the middle. Hey.
Just one more time.
No.
Come on, I got this one. I was gonna push you away.
the video recorder said no.
You're little.
Ooh. Hides behind camera. Don't pick me.
Charles.
All right. Hey, Robert.
Yeah, I don't even know who's in 7th hour. I was gonna see this.
Your mark, get set, go.
She does. Shout out Corinne.
Oh.
That's good.
Oh.
Okay, thank you for doing that.
Wait a minute.
What does that mean?
He like stopped and
This
then
can happen from time to time. So these blips all of a sudden made the position change to a really high position. Because what happened is you made the board flip up and it made the sound wave go off in a crooked direction, and so this thing didn't pick it up at the right time. So thank you for doing that.
What did I do?
So if you jump through right here, it would pick up a position that's equal.
Can I try it?
My back.
Yeah, we should just start wiggling the board in front of it.
Yeah, there's your little
Go,
sound.
Lisa!
That was like,
Perfect.
Okay,
Oh, no.
so if you want to,
That was so fun.
during another time where you have some free time, there are several graphs. So far, B and C are position graphs. A is just a blank graph, just to mess around. When you get to C, or D, I don't want to do it,
we do.
but
Let's do it. Oh, come on. Holy cow.
those are velocity graphs.
Oh, never mind, we don't want to do
Oh,
that.
just kidding.
Wait a minute.
They're really tricky.
So you gotta go
Robert.
with not-
Can we try one?
it's chicken tender dinner.
Robert said he's
You wanna
got
try
this
it?
in the back.
Roger, get out there.
I got it. Wait, what? It's in meters. Half a meter back.
You gotta move.
I got it on video. Who did that?
Oh, it doesn't matter, okay.
Wait, this is a jump? Oh, no.
Drive with some of it. Okay.
Play back and listen back.
It's like,
Yeah.
We need to go back and listen.
oh.
Roach, would you? Oh my.
you're
Oh my.
No.
Looks like a
Well, we
heartbeat.
figured out the rest of it.
Okay. Whenever you walk towards the motion detector, it's negative motion. Whenever you walk away from the motion
Beef
detector,
hoagies?
it's positive. Because your positions get bigger and bigger as you go away, so they're counting up opposite.
Oh, okay.
I know, well,
It's yesterday.
sorry, you're wrong. Okay, anyways. So graph matching, if you want to have some fun with it, you can. However, I do want to quickly show you how to do your stuff for the lab, so it's what's up 7th period. You guys know what to do. So what I'm going to do is just go through the instructions. After I get done talking, if you forget something, the instructions are posted in the assignment for the lab report for the Cart Down a Ramp lab. What? The video, I'll figure out where to post it. I haven't figured that out yet.
This?
All right, what am I, oh, so let's go here.
Wait, when is this due?
Monday.
Wait.
Wait a minute.
No, let's go back again. Okay.
Alright, quick answers. Can I go home?
So here we go. We have a motion detector hooked up to a LabQuest. This LabQuest is the thing that takes information from here and processes it and gives it to your computer so LogicPro knows what to do with it. Now I'm going to put the motion detector at the top, and what I'm going to do is I'm going to set the cart probably within 10 centimeters of the motion detector, and when I press collect, I'm going to let the cart go, and I'm going to measure the motion.
Can you do an example?
I'm going to show you, yes. So I'm going to put a new file. When I do a new file, what will happen is I have two graphs that get pulled up. That will be the same for you. A position versus time graph, a velocity versus time graph. But I need a third graph because you are going to graphically, mathematically model the relationship between position and time, velocity and time, and velocity and position. And I'll show that written form after I get done with this. So I'm going to go to insert, and I'm going to insert a graph. And LogicPro automatically thinks, hey, I want an acceleration versus time graph. Later on, you'll need that. However, today, we don't want that. So I'm first going to go to page, and I'm going to go to auto arrange, and And now the graphs are nicely stacked, position, velocity, and then this bottom one, which I'm going to change. And I'm going to change the acceleration on the y-axis to velocity, and I'm going to change the time on the x-axis to position. So now I have 3 different graphs that are going to be collected at the same time for you. Exciting. All right. When I collect data, what I want to do is, I want to basically only look at the cart's motion after I let it go and before it goes off the ramp. So I'm going to try to let this go right about the time the motion detector starts collecting data. I won't time it well enough, and I'll talk about how we deal with that. And then I'm going to try to stop the collection before the cart goes off the table. Can you catch it? And if I don't get it right away, I'm going to show you how to deal with that. So here we go.
That should be interesting.
Oh,
I'm sure it's just gonna fall.
it's all twisted. Let me do that again. By the way, it's okay if you have to do it over because the data collection takes less than 2 seconds. Okay. So I stopped it before it got off the end of the track. So now what I want to do is I want to auto scale all of the graphs from 0. And I want to have those 4 graphs. Now what you should notice, if you do this correctly, your position versus time graph should have an upward curve. Your velocity versus time graph should have a nice constant positive slope, and your velocity versus position graph should have a curve to it that's a side opening parabola. Because this is curved and that's curved, you'll have to do your steps from previous labs to straighten it out. Press stop.